All right, we're going to continue to make some conversions in part number 4. You'll notice that in this new part, let me kind of get a little bigger here, that there's more variables involved. That's pretty much to get us started and ready for the algebra that's going to be entailed for our radicals. Again, as a reminder, what we're continuing to use is the idea that when I have a radical, the nth root of a, we can now rewrite that as a fractional exponent, all right, a to the 1 over n power. So we're basically going to be using that, and again, as we were doing earlier in some of our work above, right, it's very important to understand what the radicand is and what the index is, because the index, basically of the radical, right, sits over the radicand. And so the radicand, is going to become the base, and the index is going to become the denominator of our fractional exponent. So we have to be really cognizant of the fact about what the base is and what the exponent is. So without any further ado, let's go to work. In 4a here, notice that the AB is underneath the entire radical. It's a square root. So we're going to need parentheses here. In parentheses, the entire radicand AB is being raised to the 1/2 power. All right, so that's how we make that conversion there. So again, the without the index there, it's understood that it's a 2, a square root. The base is everything that's underneath the radical. So using parentheses, we've got that. This would be different, right, if we'd have written it like this, a to the b to the 1/2. If we recall our rules of exponents, this 1/2 only applies to the b. So this would be equal to a, the square root of b. So you can see how important parentheses are. They always have been important. So in the next one, we have, again, the entire radicand is underneath the radical with an index of 3. So again, using parentheses, we have 5x y squared, and this will be raised to the 1/3 power using our conversion rule that we have there. All right, so very good. Again, parentheses, very important, and that is a 2. Here we have a break, right? We're basically having 3 being multiplied, right, to the 4th root of x. So that part right there is what needs conversion. So that's going to be x to the 1/4 power, and of course times the 3 that's out in front. Again, if there were parentheses around this, so if I had 3x to the 1/4 power, I'm indicating that the 1/4 is being applied to the entire thing in the parentheses, excuse me. So that would be the 4th root of 3x. So again, you can see from part A and in part C, and heck, even part B, how important it is to identify what your radicand is, so I know when and where to use my parentheses. In the next one, again, here's the radical part. So that converts to w to the 1/5 power, and of course that's just being multiplied to it. So we'll just rewrite it out front. Again, we have another here in part E. We do have parentheses, and they're being raised to the 1/4 power. So that means all of this is serving as the radicand. So we have a 4th root of 3x and y. All right, so that's how we convert that puppy. Again, we have another fractional exponent. It's only being applied to the x. This 7 is being multiplied, so it's kind of like what was happening in C above. So this part right there is the square root of x, and then we're multiplying it to the 7. So again, be careful about where that index is and what it's being applied to. Alrighty, and then in the next one, what we've got going for this next one is we've got, again, parentheses being used and the 1/3 power. So this 1/3 power is being applied to everything in the parentheses. So we have a cubed root, and that entire fraction goes underneath the radical. All right, so the cubed root of y squared x. Very different from the cubed root of y squared divided by x. If this was the case, we'd have y squared to the 1/3 power all over x. So again, be very, very careful about parentheses in the problem, parentheses without the problem. Matter of fact, that's what happens in H. In this case, there are no parentheses. The y is the only thing being hit by that 1/5 power. So basically what we have, right, is the 5th root of y all divided by x. All right, so again, be very clear, kind of review here. We're constantly using this back and forth. That radical notation now has this fractional exponent notation. We can go back and forth with this. The only thing we need to be very careful about is what's serving as the radicand, right? Whatever's the radicand becomes the base, whatever the base becomes the radicand, and that's the part that goes inside the radical. All right, so that wraps up our conversion phase. Let's dive deeper into this topic and some videos coming soon. Again, continue to ask questions if you've got them. Use the discussion boards. They're probably the best place to go do that, especially if you find any errors or you think you see any errors, or if you just want further discussion about the topic. I'll talk to you guys in some videos coming soon.